Hello, welcome to the new channel Study Tricks. Today we are going to learn chapter 1 of 10th CBSE Science textbook, that is chemical reactions and equations. In the previous classes we have seen what is a physical reaction and what is a chemical reaction, but we have not seen the detailed properties of chemical reactions after the reaction as well as before the reaction. This chapter gives you an introduction of chemical reactions, how they occur and what are the methods of representing a chemical reaction, and it also tells some of the functions of the chemical reactions and their properties. Now, let's begin with the lesson. In the beginning of the lesson, as we can see here, they have given us few examples like what happens if the milk is left at room temperature during summers. Students, we all know this, the milk gets spoiled. Similarly, what happens to the grapes if left for a longer duration? They get fermented and food is getting cooked. Food gets digested in our body. And what are all these? If we observe, can we get a fresh grapes from the fermented grapes back? Absolutely no. That means this is a chemical reaction. Similarly, with the first example here, the milk gets spoiled during summers because of higher temperatures. Can we get the fresh milk back from the spoiled ones? No. That means these are chemical reactions. Whenever a chemical change occurs, we can say that it is a chemical reaction. What actually meant by chemical reaction? That's what we're going to see with the help of few experiments. The very first experiment given to you people is what happens if a magnesium ribbon, specifically a cleaned magnesium ribbon, what happens if this ribbon is burnt? We can see a white magnesium oxide forming. Can we get back the magnesium ribbon from the magnesium oxide that is formed after burning? Again, the answer is absolute no. That means this is a chemical reaction. Students, you should understand one thing, why they have given a cleaned magnesium ribbon. Because magnesium ribbon surface may contain the other elements and this may cause for some other reactions and you may not get the exact answer. That is the exact product forming. Hence they have given that cleaned magnesium ribbon. Similarly, while the experiment of this burning magnesium ribbon, what we observe is a dazzling white flame evolves during the formation of white powder. Other thing that is to be noted in this reaction is it is done only in the presence of oxygen, because you know that oxygen is a good supportant for burning. The second example given to you in the textbooks is about the nitrate solution. Take lead nitrate solution in a test tube and add potassium iodide. What happens to the solution? Observe this. We'll be studying about all these experiments detailedly. First, what happens is initially we observe a temperature change in the conical flask. The other example is taking zinc granules in a conical flask, adding dilute hydrochloric acid or sulfuric acid, that is nothing but a zinc granule with any dilute, that is a minute quantity of acid added to zinc granules. What happens? As it is an acid, it is going to burn zinc granules to a certain extent. We are taking dilute, so it will not completely burn. What happens in this? Either we may see a color change or state change or temperature change. What are all these? See, as given below, whenever there is a change in the state means like a solid granules may be getting converted to a liquid thing, or the color of the taken reactants changing, or evolution of certain gases. Like in the second example, we have seen the potassium iodide reacting with nitrate solution. There are certain amount of gases, fumes evolving, and in this, that is zinc with any acid, it liberates hydrogen gas. Like this we see the evolution of gases from the conical flasks and change in the temperature. All these happen when there is a chemical reaction going on. We have seen what happens in a chemical reaction. Literally we have seen what are the the constituent elements and what are the product elements. Now let us see how a chemical equation is represented. We have seen how it is done in a laboratory but not how it is represented on the paper. Coming to the representation of a chemical reaction on the paper, we are going to learn different methods. Like, remember the first example was burning a magnesium ribbon. Burning, that is in the presence of oxygen. So magnesium plus oxygen reacts and forms magnesium oxide. In a chemical terminology, the things which are getting reacted are known as reactants, and the final product which we get in the test tube after our experiment is the product. This is represented as magnesium plus oxygen giving rise to magnesium oxide. The same in a formula thing we write as Mg, that is formula of magnesium plus O2 gives rise to MgO. Now, the substance that undergo chemical change in the reaction are reactants. That means here the reactants are magnesium and oxygen and the product is magnesium oxide. This we have seen. I think as far as we have covered, it is clear, crystal clear. Now, the equation which we have seen here, like Mg plus O2 giving rise to MgO, is in chemical terminology known as skeletal chemical equation, because the main skeleton of the equation is written here like Mg plus O2 giving rise to MgO. We have not balanced this equation. What do you mean by balancing an equation? Balancing an equation means number of atoms present on the reactant side should be equal to number of atoms present on the product side. Here, what are the reactants? Magnesium plus O2. How many molecules of magnesium are there? 1. How many atoms of oxygen are there? 2. In the product, we are seeing only 1 magnesium atom and 1 oxygen atom. That means this is not balanced. Now, we will see the methods and how we can balance a given chemical reaction. Like, see, they have taken an example like zinc with sulfuric acid, which we have seen as a part of our third example. Zinc plus sulfuric acid, not specifically sulfuric acid, it can be chloric acid also. Any acid with zinc. That means this reaction, I have said you previously that it liberates hydrogen, that is zinc sulfate plus hydrogen. This is the reaction zinc Zn plus sulfuric acid H2SO4 giving rise to zinc sulfate plus hydrogen gas liberating. Now we'll see number of atoms of reactants on the left hand side and the number of atoms in the product side. In the reactant side, only 1 atom of zinc is there, so 1, and hydrogen there are 2. Sulfur 1, oxygen 4. These are as a part of H2SO4. Similarly, on the product side, number of zinc atoms is 1, sulfur is 1, oxygen is 4 and hydrogen is 2. We can see it is clearly balanced, right? 1 zinc in the reactant and 1 zinc in the product. Similarly, with other constituent elements, it is completely a balanced equation, as the number of atoms on each element on both sides of the arrow, that is on reactant side and on the product side, is equal. Hence we call it as a balanced equation. And see the second equation, ferrous reacting with water, ferrosoferric acid, Fe3SO4 is ferrosoferric acid. Otherwise, ferrous oxide and ferric oxide combined together, that is FeO and Fe2O3. Ferrosoferric oxide liberating hydrogen. In this, see whether the equation is balanced or not. See number of ferrous on the reactant side, it is only 1, and the number of ferrous on the product side is 3. That means this equation is clearly not balanced. How can we balance this? That we are going to see in the next session. Keep tuned with study tricks for more lessons and stay home, stay safe.